Advances in Character Recognition. This course is brought to you by Gilad James Mystery School. Learn more at giladjames.com. Introduction. Handwritten character pattern recognition methods are generally divided into two types: online recognition and offline recognition. Online recognition recognizes character patterns captured from a pen-based or touch-based input device where trajectories of pen tip or fingertip movements are recorded, while offline recognition recognizes character patterns captured from a scanner or a camera device as two-dimensional images. Both online and offline recognition methods can be roughly divided into two categories: structural and unstructural. Unstructural methods are also called statistical methods or feature matching methods. Structural methods are based on stroke analysis and use structural features such as sampling points, line segments and/or strokes for offline recognition and for online recognition. Unstructural methods use unstructural features such as directional features, gradient histogram features and projection features such as those for offline and online recognition, which eventually achieve stroke order independence. Structural methods are weak at collecting global character pattern information, while they are robust against character shape variations. In contrast, unstructural methods are robust against noises but very weak against character shape variations. By combining a structural method structural recognizer, with an unstructural method unstructural recognizer, the recognition accuracy improves since they compensate for their respective disadvantages. For online recognition, structural features are often employed with hidden Markov models, HOMs, or Markov Random Field, MRF. However, since the UN structural features are easily extracted from an online handwritten pattern by discarding temporal and structural information, we can apply the UN structural method as well. Therefore, we can combine the structural and unstructural methods. Freely written string recognition. In freely written string recognition, we need to consider whether we should select segmentation-free or over-segmentation-based methods. Character segmentation of cursive handwriting is difficult due to the fact that spaces between characters are not obvious. Without character recognition cues and linguistic context, characters cannot be segmented unambiguously. A feasible way to overcome the ambiguity of segmentation is called integrated segmentation and recognition, which is classified into segmentation-free and over-segmentation-based methods as shown in segmentation-free methods, mostly combined with hidden Markov model, HMM-based recognition, simply slice the word pattern into frames, primitive segments, and label the sliced frames, which are concatenated into characters during recognition. Such methods do not sufficiently incorporate character shape information. On the other hand, over-segmentation-based methods attempt to split character patterns at their true boundaries and label the split character patterns. Character patterns may also be split within them, but they are merged later. This is called over-segmentation. It is usually accomplished in two steps: over-segmentation and path search. The string pattern is over-segmented into primitive segments such that each segment composes a single character or part of a character. The segments are combined to generate candidate character patterns, forming a segmentation candidate lattice, which are evaluated using character recognitions incorporating geometric and linguistic contexts. However, character segmentation is a hard problem to solve. When handwritten words are not easily segmented, such as with cursive writing, over-segmentation may result in misrecognition. In this case, a segmentation-free method is appropriate. For Chinese/Japanese recognition, however, segmentation is easier than in English or other Western languages. Segmentation-free offline word recognition methods using unstructural features in sliding windows combined with hidden Markov models, HOMs, and those using over-segmentation-based methods can also be considered as unstructural methods since they use unstructural features. Since over-segmentation-based methods can better utilize character shapes, they are considered to outperform segmentation-free methods. Moreover, over-segmentation-based methods produce less primitive segments since they attempt to find true boundaries of character patterns as segmentation point candidates. Therefore, we consider that over-segmentation-based methods are effective and more efficient compared with segmentation-free methods for Chinese/Japanese string recognition. We show our online handwritten Chinese/Japanese string recognition system in Figure 2, where an over-segmentation-based method is used. In this lecture, we describe the recent technology trends, problems and methods to solve them for the online Handwritten Chinese/Japanese character recognition. The rest of this lecture is organized as follows. Section 2 presents an overview of our online handwritten string recognition system. Section 3 presents structural and unstructural recognitions. Section 4 describes course classification. Section 5 describes combination of structural and unstructural recognitions. Section 6 presents string recognition, and Section 7 draws conclusions.